So hello again. Just well, as we are running quite late today, but I think it's worth it, and we have a full day for this. So, as I said, the next block will be. We have a more practical approach, and we will have Tyris and Ineco showcasing us the practical use cases that they have developed and that they are currently implementing in their respective businesses. The first one will be presented by Txus Blasco. I'll explain you a little bit who's Tyris. Tyris AI is one of the partners of our project, of the European project in digital twins. They are a company based in Valencia, a very young company, but they're still fast growing because they are simply disrupting the market with the application of the new technologies, artificial intelligence, and development of software and development of solutions and based in artificial intelligence, machine learning, etc., to optimize processes, to optimize maintenance or predictive maintenance. And today we will have the pleasure of learning from Txus. Txus Blasco is, correct me if I'm wrong, he's a Master in Science in Mechanical Engineering from Universidad Politécnica de Valencia. He's also currently going through the hell of his PhD in data science and machine learning. He's quite an expert in that. And he joined Tyris quite recently in November. But beyond that, he has a very innovative and entrepreneurship spirit. He has made his own ventures and will show us what are they doing today at Tyris. Thank you very much, Txus.
Thank you very much. Thanks a lot. So, yes, I am Txus Blasco. My pronouns are he, she, or they, whatever. And I am an industrial engineer. I have a master's degree in aerospace engines, not in digital twins, but I could be working with you because I like this subject very much. And I am a student in a PhD for computer science, and my topic is uncertainty quantification of neural networks, this time applied for financial prediction. And currently, I am project manager at Tyris AI, and I wasn't always a data scientist. I was starting as an engineer working in the automotive industry. In fact, in my early stages of my professional career, I was working as a development engineer, not in the software field, but in the physical things. I was designing and building plastic parts for the automotive interiors. And now, well, I am working at Tyris, and I wanted to do some years ago a change in my career. So this is why I wanted to go through something more abstract, towards data. Well, many engineers are twisting their careers towards data, and that was my case as well. And that happened because I realized of this, because every company is a data company, whether they know it or not. Ford Motor Company is a data company. Eventually they sell cars, but they are a data company. Inditex is a data company. Mercadona is a data company. Even universities are data companies. And this is what we do at Tyris. We are an engineering company using artificial intelligence for the industry. What we are doing is helping our customers to understand that they could exploit further their potential in data, that they could acknowledge their assets, data assets, and to push them further and get the quality and the quantity of data and help them to be real data companies. This is what we do. Tyris AI is a subsidiary of a bigger company called Tyris Software. And Tyris Software is made of 100 professionals. And Tyris AI is the advanced analytics specialized company from Tyris Software. And we are made of 25 machine learning engineers, software architects, industrial engineers like myself, and PhDs in the artificial industry. And we work together to push further the challenges of the industry 4.0. And at Tyris, we know, not yet. At Tyris, we know how important it is to cover the whole data life cycle from the beginning to the end. And this is why we are treating and we are dealing with data sources from the early beginning, from the acquisition phase. We treat data, we squeeze data, we do whatever is necessary, and we extract the most relevant pieces of information so we could feed algorithms, we could feed models that we are making on our own. And finally, we provide end solutions to the industrial, our industrial customers. And to that end, we are based on 3 pillars. And these are the 3 pillars. The first one is data integration. What does it mean? It means that we go to the industrial environment and we connect our own sockets to whatever is there, machines, databases, IoT devices, whatever. And as an example, we are developing right now a project, European projects, in which we are connected to a plastic injection machine. And, well, plastic injection machine is made of one mold, which is made on 2 hubs, and the plastic injection is injected inside. And if we achieve this is a European project of research and development, but if we achieve this, we will be revolutionizing the way data is acquired and processed. Why? This is the example. We are reading pressure and temperature from the injection molding, and we are doing it through industrial protocols. This is, let's say, the first step. The second step is the data analysis and the model training. And this is where the cool things start to happen. These are, let's say, funnier because we build things that are that can be seen as what you see outside. It is artificial intelligence models that do things and make decisions on data. And in the example that I just posed, our model made by the consortium, it is a very big consortium made of more than 10 companies in all around Europe. Our model will be able to say something like, hey, I know that you have here pressure and temperature, so you need to know that the next part, the next plastic piece that you are going to take out of the machine is not going to be okay. It's going to be a failure in terms of quality. But not only that, in the last stage of the project, we need to achieve something like the model telling to us something like, I don't only know that your part is not going to be okay, but I know the combination of pressure and temperature, so your part is okay at the end of the process. And this is closing the loop. I mean, the model is telling us what are the parameters that we need to set in the machine. And this is why I was explaining at the beginning that I was an industrial engineer. I was spending weeks in the industrial environment trying to find the best pressure and temperature combination of parameters, and that was really difficult. It was trial and error, and that was just 10 years ago. And look at where we are now. We're able to say, okay, we have a model which is doing the work, not with the human outside the loop, but inside the loop. And finally, we do the system implementation. And this is closing the end-to-end product that we are delivering. We build dashboards, we build interfaces, so we can interchange information with the machine, with the models. Okay, and I'm going to be shorter than compared with my colleagues, and I was bringing several examples here, and what you are seeing here is a battery from an electrical vehicle, and what you see is an artificial intelligence model that we have done on our own. We don't reuse commercial models, existing models in the market. We use our own. So as you can see, this battery is inserted in a vehicle, but sometimes you need to understand that the operators are going so fast building the car. They are plugging the connectors, those connectors in the car, and sometimes they are not plugged correctly. The thing is that when the car is finished, and this is at the end of the production line, if somebody in the testing facilities are realizing that these plugs are not correctly plugged, it is a cost problem, because they need to dismantle the rear of the vehicle and try to find what is going wrong. I can see what is wrong here, and you could also as well, because if you see this connector is not correctly plugged. But I know it because I'm a human, but the machine, well, we train it so it is, let's say, easy for them. So it is correctly identifying those connectors that are rightly connected to the battery and those who are not. Let's go to the next example. This is my colleague Jordi, indeed. I will put it. We have developed another model that is detecting it is first detecting persons, it is then detecting vests, and then detecting the cap, the hats that my colleague is wearing. So this is a safety application. Sometimes in the industrial environment, some operators are taking out their vest, and that poses a safety problem. So whenever the model is detecting that there is a person there, but is not wearing the vest or not wearing the cap, it raises an alarm somewhere in the environment to say, hey, this person is not wearing the right PPE, the personal protection equipment. And also, I was remembering our Asunción was mentioning the GDPR, and you can understand how difficult is also this, because you need to identify people, but not in such a way that you can identify everything that is this person is doing in the environment. So this is a special case because it is a safety issue. But in other case, for example, in the case that I was mentioning before, with the pressure and temperature in the injection molding plastic, we cannot do things like creating a data set. We are gathering data every second, pressure, temperature, but we cannot do things like, okay, so from 8 to 12, there is one person working on this, and then from 12 to 4, there is another person, because that would pose a GDPR issue. But sometimes we need something similar to that, because sometimes we don't know why the labeling of the data sets are not the same. So, well, issues and challenges in the industry. I have another example here, which is stairs. This is a static camera in a commercial establishments, and as you can see, this person is doing something wrong. First, he was going up in the stairs, but then he was going on the other side, and that is detected as something that should not be happening. For example, if that person would be taking his arm outside the stairs, that would be raising an alarm as well. So this is the kind of things that that we are doing. Okay, another example. These are indeed my colleagues at the office. We were testing the models that we were building. I can tell you we're having fun. We work sometimes, but we're having fun. So as you can see, the model is detecting that one person is standing and one other one is sitting down in the floor. This can be used for detecting postures, human postures that could be harmful for the people, for the operators, for the workers. If I am acquiring a posture, a bad posture, a model can tell, hey, this person is not doing it right, so don't do that, stop doing that. And this is another example. This is an overhead conveyor system. This can be found in industries like, well, every automotive industry has a system like that. And this is like you have kilometers of the rail that this conveyor system is following. The thing is, and I wanted to show you this, not so you don't think that everything that we do is in artificial vision, but this is data. This is data prediction. We are analyzing, or the industry is analyzing electrical patterns in the conveyor systems, in these carts. And when the pattern is detected to be anomalous, then that particular car is separated out of the rails and it is repaired. And it is because every minute or every hour the industrial environment is stopped, they are losing millions. Imagine Ford is getting out 2,000 cars per day. So they cannot afford to stop 1 minute the line. This is very, very critical in terms of cost. Okay, so I'm going to go a little bit deeper in terms of technicalities. This is a pipeline. This is the typical pipeline that we implement in the industrial environments. And this is a plant, an industrial plant. We can get data in real time and process that data in real time from databases, our IoT devices, machines, whenever you can think of. And we are doing it through connectors, sockets, the blue thing. This is the sockets are made and are built by Tyris, and they are used for translating the data going through industrial protocols like Profinet, Profibus, OPC UA, OPC UD. Okay? And then we use big data approaches to treat that data, to process that data. The first ones are the first pillar that I just showed you before. And we are using stacks like, for example, Apache Kafka, Apache Hadoop, Spark, Storm, and those are, let's say, those are stacks that make people think that the most difficult thing in the data pipelines are the models, for example, the neural networks. But it is not true. the most difficult thing in data, at least in industrial environments, is acquiring and having labeled, usable, and useful data. It is, I mean, imagine and remember the videos that I showed before. I showed you before. We need terabytes of labeled videos to tell the machine learning models how to behave and how to be trained. And that needs to be manually, or maybe we need to use advanced analytics like data augmentation or any other technique, like for example, the generation of synthetics in data. And then we have the models. Then we have the neural networks. And we do them in Python. As I said, usually we don't use commercial models. We build them by ourselves because we make ad hoc solutions for the industry. So every application is different. So we need to start from scratch always. And finally, what we have here is once we have the output of the model, we can monitor the outputs and the responses from the artificial intelligence models in dashboards that we also build. We use things like Vue, for example, React, or Django. So our client has a whole data cycle implemented in Plant. Okay. And well, we have seen several applications of machine learning in Industry 4.0, but how does it translate to digital twins in the civil infrastructure industry? Well, let me tell you something, and if you are going to retain something from my intervention, retain this. Industrial plants and civil infrastructure objects are exactly the same from a data perspective. So in such a way that I can do this. It is as easy as that because we have sensors. We are acquiring data. And also, well, it is, we have a manufacturing plant, and it is not static, it is dynamic. But a building, an infrastructure, it is also dynamic. And yeah, a building is alive from a data perspective. And there are always things happening. Don't think of a building, of a infrastructure as a concept, as static as a concept, which is used for conceiving the work, conceiving the building, and once the construction is finished, it is done, and it is not used anymore. Maybe in the past it was like that, but it is starting to change. It is becoming differently. And yeah, because buildings get old, infrastructures get old, so they are always changing. And now, with sensors, we can track those changes. For example, we have here, this is another project that we have done. It is a picture, it is not a video, but I have a video of this. We have done this with one of the most important construction companies in Spain. And what you are seeing is that they wanted two things. They wanted drones, and they wanted vehicles on the road that they could get and acquire visual data from the road. So this is the results. This picture was taken by a drone, and they can detect potholes, or they can say something like, and this is more interesting, even more interesting, like warning, there is a high CRT here. Something is going to happen in the future. Okay? So, yeah. So let's talk about the BIM. The BIM is representing, or traditionally, it was representing the past of an infrastructure. It is like a passport. It is a virtual representation of what happened in the past, and it is including technical decisions, design decisions, contracts, 3Ds in the best of the cases, but not always, and many, many things. But now with sensors, we can not only represent the past, but we can also represent the current state of the infrastructure, as in this case. At Tyris, we are able to acquire this data in real time now. And yeah, you can do things like, for example, to acquire data to say if there are cracks in the environment. Is there any displacement of the structure? Are there any water leaks in the building? Is maybe, I don't know, an aluminous case in the building? And because we have artificial vision, we can take that information. We can take infrared images. We can take thermal images. Maybe multispectral images, X-ray, whatever. Even sometimes companies are talking about making chemical analysis in real time. And not only that, but also the big construction engines are starting to think, and I'm very glad that you spoke about that. They are tending to include models in the BIM, but this technology is not yet fully implemented, and it is staying in the research and development domain and innovation. We are starting to do that. I want to show you the video of the results. This is the model in action. This is what it is detecting. The white thing are the cracks and are not okay parts, not okay pieces of information that can be gathered in real time. Okay. So this leads me to something that in Tyris we like to call what-if functionalities. Well, a digital twin is a virtual machine, isn't it? It is something that is representing the reality, but not really everything. It is like a simple model representing the reality. And as such, we can simulate a normal behavior. We can simulate something that is happening to a bridge. But this is very interesting because with what-if functionalities, you can do things like simulate abnormal situations. So now that we have a digital twin, we have the BIM, we have sensors, and we have real-time acquisition of data, and we are in the time in 2024 trying to include artificial intelligence models inside the BIM, so we could represent what will happen in the future, but not in normal conditions, but in abnormal conditions. And this is not as easy to do because a 3D or the, let's say, traditional linear simulation is not enough. We need to implement advanced analytics so that is happening. But we still don't know how to do that. We are spending a lot of money in the Commission, European Commission, and they are funding a lot of projects trying to do that, trying to fit artificial models inside the BIM. And yeah, as I said, the industry is seeing the BIM as simulators. Simulators not only for the present, but also for the futures. And I can provide you with an example of a project that will start at Tyris this year, for example. Regarding a bridge like this one, you have the pillars. I am not an expert or an architect. I am in the industry 4.0, but I will try to explain what I know. We have the concrete pillars, and then we have like concrete platforms, and between them we have something called like shock absorbers, and they are made of neoprene. So one thing that we are trying to predict, is to link and make a model linking the traffic volume, like this one, with the predictive maintenance of the bridge. We are not trying to build a model to know if the bridge will withstand charges or resistance. This is something that we already know how to do. But we are trying to link that with cost. This is cost. I mean, if I need to take the traffic to a different road, so I could decrease the maintenance of a bridge, and instead of doing an analysis and a visual inspection of it every 2 months, if I can do that every year, I am saving money. So this is why the industry is going this way. So, as I said, we're at a very interesting point in time. Very few companies apply the technology in this way. And what can we do to push further the state of the art? What can we do to include all the artificial models, the sensors, and the digital twins together, these 3 legs of that table? Well, through research and development and innovation. And this is what one of the things that we are doing at Tyris. There is a program called Horizon Europe. There are many other programs, national ones, regional ones, but this is one really interesting from our side. And just to name a few, we have 2 projects that are ending right now. One is Teaming AI, and Teaming AI is trying to make a digital twin of the industry 4.0, including artificial intelligence models. So what are we trying to do? And I feel especially attached to this project because I was the development engineer in charge of trying to find the pressure and temperature combinations in that machine. So now that a machine is doing it, so what is my role? Some people think that, well, the humans are going to be replaced, but I don't think that's the case, to be honest. At least the European Commission, and at least in Europe, they are putting a lot of effort to keep the human in the loop, to keep the human in the center. So everything that is raised and funded by the European Commission still needs to have the human inside. So I, as a human, I am part of the model. I am part of the system, because, and you can see it in ChatGPT. ChatGPT is still not able to be autonomous. Sometimes it is silly. It makes, well, it has hallucinations, as our colleague was saying before. So we are still here. So we need humans to make interpretation of the results. This is why we cannot get out of the equation. The other project that we are doing is called XMANI. XMANI is still putting the human in the loop, and it is touching something called explainable AI. Maybe you have heard about that. And this topic and the other one that I'm going to mention, I guess that this is going to be one hot topic in the future from a scientific and technological point of view. Asunción was mentioning also before about explainable AI. Neural networks and other machine learning models are black boxes. It is very, very difficult for us data scientists to know why the model has made the decision it made. We don't know that, because it is in a mathematical model inside, and there are many neurons inside, and every neuron is taking one decision and is making a tiny thing, but we don't speak mathematical language. We speak human language, so we don't understand what is happening here. So explainable AI is trying to open the black box and trying to let us humans know about features. For example, well, it's very difficult to say without a picture, but if I need to make a difference between a cat and a dog, I could be taking into account, for example, the size or the ears or the legs of the cat or something. So this is something that I, as a human, can understand. So this is one of the projects. And the other topic that and this is my feeling, okay? My feeling is that uncertainty quantification is going to be one of the legally hottest topics in the future. And what is this? This is sometimes ChatGPT is providing you with an answer. If you ask, it is providing you an answer. But is it a correct answer? How can you know? Because you don't know how it took that decision. How was the decision made? And uncertainty quantification is about coupling statistics and coupling machine learning together, so the output that we have is understandable from a, let's say, uncertainty point of view. For example, instead of predicting points, or instead of predicting concrete things, trying to predict confidence intervals. And this is especially critical in medical devices, for example, or maybe, well, you come from construction. Maybe there's a parameter which is critical. So it is not enough to have one single number. If I am going to predict the behavior of a pillar or something, I don't want to have just one number. I want to have a tolerance. I want to have a confidence interval. So uncertainty quantification is a way to let the humans know whether how sure or unsure is the neural network about the result that it is making. And just to finish, Horizon Europe is one of my favorite programs because it is, it is very, very interesting from many points of view, technical point of view, also, of course, economic point of view, but it is really pushing Europe to the next level. And they are, of course, financing things and financing projects like that are treating CO2 reduction in the infrastructure industry, circular economy. I'm just naming a few so you could have that in mind because you will, of course, deal with that in the future. Sustainable development, increased human safety. And the type of projects that companies like Tyris is presenting to European calls have to do with that, with increased safety. And if we can have a drone, if we could have sensors when a construction is being built, if an infrastructure is being built, we are taking the human outside the dangerous things, the dangerous spaces. This is one of the possibilities. And yeah, that's it. This is the end of the presentation. I hope you enjoyed and it was like practical enough. And please let me know if you have any questions.